Now in this what to say, that is now in this video we will see that that is overload or overload error, and another one is nothing but over voltage error. Okay, the first thing we will see is nothing but overload error or over current error. Okay, first thing, overload or over current error. Okay, basically what it means that see, we already know that uh, in energy meter we are going to have that two magnets. One is shunt magnet and another one is nothing but a series magnet, and both these magnets will produce their respective fluxes. Okay, so and the disk is rotating in between them. So when disk is rotating, that disk cuts this uh, series flux. Okay, series flux, then there will be a dynamically induced EMF because of this series flux. Okay, then there will be dynamically induced currents in that disk of that disk. Then what happens? Then these eddy currents will react with the flux of this series magnet. Okay, and produces a braking torque because of that Lenz's law. Because these currents are induced because of that relative motion between the series flux and this disk. So because of Lenz's law, the effect will oppose the cause. The effect will oppose the cause. So that means it opposes that relative motion, because the cause here is for the induction of that dynamically induced currents is the relative motion between series flux and this disk. So it will oppose that motion at higher currents, at higher load currents, and this opposition or this braking torque is proportional to square of the load current. Okay, this braking torque is proportional to square of load current, because the torque is proportional to flux into I. Here this flux is nothing but series flux and current is nothing but the load current. That okay, current is nothing here. No, here that braking torque is proportional to that load current square. Okay, load current square. That one thing we have to remember. Okay, I think you have understood this thing. Okay, but in case of that production of the torque, actual torque in actual torque, the deflecting torque, there the torque is produced because of the flux produced by series magnet and eddy currents induced because of that shunt magnet. Okay, that is the thing. Here it is not an eddy current, not because of time varying flux cutting that disk eddy currents, not here. Here that braking torque is nothing but because of that what to say, relative motional thing. It is not an static current, not static current here. Okay, so I will write this thing. What it means that when disk rotates, then dynamically induced EMF in disk because of relative motion between disk and series magnet flux. Okay, then currents are generated in disk, because since EMF is there, no, then currents will be there. What are these? These currents are dynamical currents, motional currents, not eddy currents. These are motional currents. Okay, then what will happen? These motional current, react with field of series magnet, that is phi SC, and produces self breaking torque. This is not the breaking torque produced because of permanent magnet. This is another thing here. This whatever explanation is done, that torque here. Okay, and why it is happening like this means because of Lenz's law. Lenz law states that effect opposes the cause. Here, what is the cause? Relative motion between disk and phi SC, and effect is nothing but motional currents. Then that is motional currents will oppose the motion of disk, which is nothing but relative motion between that phi SC and the disk, that is motion of disk. Okay, that is motion of the disk. Then what to say is that this self breaking torque, whatever it is there, no, this self breaking torque, whatever it is there, no, it will be proportional to the load current square, because it is produced because of that series magnetic flux, and series magnetic flux is produced by the load current. That's why it is the load current. Okay, load current, so it opposes the motion of that disk. Okay, load current square. So since this self break torque opposing the motion of disk, the meter reads lesser value at a higher load currents. This will happen only at higher load currents. Okay, higher load currents, because at higher load currents only the flux will be very high, phi sc. So if the flux is very high, that phi sc is very high, then self breaking torque will be very high, because self breaking torque is proportional to the load current, it will be very higher. So that is at a higher load current values, the self breaking torque will be more. Okay, so the meter will leads the lesser value, because whatever that number of revolutions made by that disk there, no, that will be equal to that energy reading in that meter. So if that we are here, that self breaking torque is opposing that motion of the disk, no, so then that meter will lead lesser energy. That is the thing, that's why it is getting the lesser energy. Okay, now remedy. Now remedy, what is the remedy will be? Now what the remedy is nothing but whatever this is getting that overflux, now over series flux at higher load currents, at higher load currents, that overflux, what we will do, we will made not to touch that disk. Then if that disk is not touched with that overflux, over series flux, or flux produce over series flux, or over series magnetic flux not touching the disk, then that self breaking torque won't be there, no torque will be generated, because no flux means no torque, because torque is generated because of the interaction of that flux and that eddy currents, no, that emotional currents, no. So no, not flux touching that disk means then no self breaking torque, then meter will read normal reading. That is the thing. Okay, that is what self breaking torque is reduced by making or reducing the full load speed of disk, full load speed of disk, and making phi sc less than phi p, where phi p is nothing but, this is nothing but over flux, over series magnetic flux. Okay, that is the then which reduces that dynamically EMF, because EMF induced in that disk, motional EMF is nothing but BLV, where V is nothing but the relative motion between that disk and that series flux. So if that speed of that disk is reduced means, then whatever that EMF, amount of EMF induced in the disk will reduce. So if that EMF reduces, then motional current will reduce. If that motional current is reduced, then self breaking torque will also reduce. That is what it is saying. Okay, hence the self break torque reduces. Okay, this is one method to reduce, and another method I have already said, no, that is we will not made to touch that that overflux with the disk. Okay, this another method is phi sc is made to not, this is overflux, not actual flux, overflux only, not touch the disk at overloads, at higher load currents, at high load currents only, but not for normal load currents, that phi sc will touch the disk, then only rotation is possible. By shunting the phi sc through saturable series magnet. Saturable series magnet. And how it will look, I will draw that saturable series magnet. This is that actual series magnet is there, no? And we are going to have the disc like this. This is the disc, okay? And that saturable series magnet will be there like this here. Okay, then whatever that series magnetic overflux under high load currents, it is providing the lesser reluctance path. It will pass through like this, and it is not made to touch the disc. Okay, this is what that flux diversion. This is the flux diversion. Okay, and this is nothing but this red color is nothing but series saturable series magnet. Okay, so in order to remove that overload error or overcurrent error, we are going to use an saturable series magnet. And similar to the above explanation, we are going to have another error in induction energy meter. It is nothing but over voltage error. Over voltage error. Over voltage error. This over voltage error is also nothing but the same case only because of this over voltage. Over voltage error is caused because of that over voltage. That is this whatever that shunt magnet is there. No, that shunt magnet is going to produce that phi sh. So under overload under over voltage conditions, this shunt magnetic flux is going to cut that whatever that disc is there, no, rotating disc, it will cut that rotating disc. Then there will be an motional EMF induced because of that shunt magnetic flux. Then there will be induced currents in that disc because of this motional EMF. Then what happens now? Lenz's law again it will come. Then Lenz's law it will come again. That is, this induced current will actually oppose that cause. What is the cause for that motional induced currents? That is the relative motion between that shunt to overflux and that disc. So what it will do? It will try to reduce that relative motion. That means it will try to stop the. It will try to reduce that motion, relative motion between that shunt flux and the disc. That means it will slow down that disc. That is, a self-braking torque is developed in that disc. In the similar way, what we have discussed that over current error. Okay, that is what this thing. That is what this overload error, this over voltage error is nothing but because of voltage variations. Because of voltage variations or over voltages. This shunt magnetic flux produces, and this is an overflux, produces a dynamically induced EMF in disc, and then again Lenz's law will come, self-braking torque, then self-braking torque which will be proportional to that load voltage square, which will be proportional to the load voltage square. That means self-braking torque there means then that disc will won't rotate. There is an opposition. So we need to reduce that overflux, shunt overflux. So if the disk movement slow downs, then what it will, that meter will read the lesser value, because whatever that energy read by that disk is proportional to the speed of this disk or number of revolutions. So if that disk is slowing down, then it will read lesser value. So we need to reduce the shunt overflux. That is, we should not make that shunt overflux not to touch that that not to touch that disk. So this is made by using two things. One, by using an saturable shunt magnet, which is similar to that saturable series magnet, and another one is nothing but on the shunt magnet we are going to produce the holes, that is the reluctance is provided for that because of that holes reluctance will increase, air holes, then that automatically that shunt flux will reduce. Even that over voltage increases, that shunt flux will reduce. So that self braking torque produced will be reduced, because self braking torque is proportional to that voltage square or that shunt flux square, because that only causing that self braking torque interaction between shunt flux and that motional current. Okay, that is 5sh is an overflux. Is reduced by using saturable shunt magnet, which diverts the shunt field and not touching the disk at over voltage conditions. Okay, and other way is nothing but 5p is also reduced by increasing the reluctance of shunt magnet iron by including air holes on sides of that shunt magnet, because air has more reluctance. Why? Because the relative permeability of air is less 1, so S will be equal to L by mu 0 mu r into A. So this mu r is lesser value, so reluctance will be more. That is the thing. How that diagram will look like this, I'll draw it in next page. How they will that shunt magnet and that saturable shunt magnet will look like, we'll see. This is the shunt magnet of the energy meter. So we are going to have that saturable shunt magnets like this, and below this we are going to have that disk. This is the disk. So now whatever that shunt overflux is there, no, that overflux will take path like this. It will not touch that disk. Okay, it will take like this. It is not micro touch. And another way is nothing but to put the holes here like this. If you put holes like this on the sides like this here, then the reluctance path of that first shunt will increase and this flux will reduce, then self braking torque will reduce. Thank you. This is about these two errors.